Turn your volume. Okay. Why?
Only going to be one way to submit questions, right? Because it's a little bit tricky. She was presenting to us through Zoom. She wasn't able to make it out after all. So if you want to ask a question during Ella's chat, you need to submit it on Slack. That way I will be up there and she'll actually be able to hear me, but she won't be able to hear any of you, right? And that's the way that we're going to ask her questions during the Q&A. And you guys, if I can have your attention for a minute, hi, you know we have attention for a minute, thank you. Okay, so Ella Morawski, Program Director at SBIR, actually a pretty serious VIP. Normally she requires a minimum of 100 people to agree to do a talk.
I wouldn't. So no music. Can you turn the music on? Okay. Hello, can you hear us?
Yes, I can hear you. Can you hear me?
Good. Yes, we can hear you. So feel free to share your screen.
Sure. Let me go to presentation mode and switch. Is that good?
I think we're seeing your presenter view.
Okay. I'll just swap these then. So let me stop share because if I do it the other way, it doesn't fine. Is that better?
Same, that's showing the same actually.
Escape. I those. Now it's going to be right. How about now?
That looks good. Yes.
Great.
Ella, you can go ahead and start.
Great. Well, thank you all for being here. I appreciate the efforts that you're making to, try to find technologies and apply science to be able to make the world a better place. And so I'm here to discuss, funding that invention to impact pathway, specifically about programs that are available at the NSF, and in particular, the new Technology Innovation and Partnerships Directorate. My name's Ella Morawski. I'm a program director for the SBIR STTR program, and the portfolios that I manage are advanced manufacturing, mobility, semiconductors, photonics, energy storage, battery technologies, and I also help out with environmental technologies and also advanced materials. So just to give you a little bit of background on the NSF by numbers in FY21. So basically, NSF, 94% of the budget is used to fund research, education, and related activities. In 21, we had about an $8.5 billion budget that was approved by Congress. We evaluated over 43,000 proposals that were submitted to our program. There are about 12,000 proposals that were awarded that year, funding approximately 2,000 institutions. And we invest about $1.4 billion in STEM education to really try to drive that knowledge base and scientific knowledge base in our country. Our program, basically as NSF, has translational activities. There's about $200 million that are dedicated to seed public-private partnerships at this time. That's continuing to grow. In 2022, our priorities as related to the current administration are to enhance fundamental research and development, strengthen U.S. leadership in emerging technologies, advance equity in science and engineering, also advance climate science and sustainability research, and then continue construction of forefront infrastructure to support translation of scientific discoveries into impact that touches society. So we have a new directorate that was rolled out on March 16th of 2022. It's the Technology Innovation and Partnerships. And the mission of that directorate is to enhance use-inspired and translational research. So, NSF typically funds a lot of fundamental research, and then that is, you have the benefit of being able to see new scientific discoveries come to fruition in the laboratory. And the goal then is to determine when and if we can, facilitate moving those discoveries out of the lab and into commercial markets. And how quickly can we do that? Is there a way for us to be able to basically facilitate that through this directorate? So the other aspects of this new directorate are to be able to grow the economy and create new jobs, and also strengthen and sustain U.S. competitiveness in the technology areas, and also to support NSF's main mission, which is to improve Americans' way of life. The 2023 President's budget request for NSF is increased from 8.5 billion to about 10.5 billion. And so it's about 19% higher than what was enacted in 2022. We anticipate that the Directorate for Technology Innovation Partnerships TIP will receive about 880 million. And there are several focuses in that directorate to include advanced manufacturing, artificial intelligence, advanced wireless technologies and biotechnologies, microelectronics and semiconductors, and then also quantum information science. And the goal here really is to also look at how these can be approached from a cross multidisciplinary perspective. So there are several realign investments. So the SBIR STTR program, also known as America's Seed Fund, was originally aligned in the engineering directorate. And so there are several programs that have moved into TIP. Those include I-Core, which is the Innovation Core, Partnerships for Innovation, which is PFI, SBIR, CTR, and then also Convergence Accelerator. There's several new programs that are being developed through new investments that are being requested in the budget, and that is, innovative pathways for technology translation, emerging technologies, experiential and entrepreneurial learning, and then regional innovation ecosystems, and then also programs to accelerate partnerships. And the one highlighted here in yellow is the one that will be rolled out first as this directorate grows. And so the illustrative example we like to use to sort of describe, a sort of small version of a regional innovation ecosystem is this partnership that was recently made between Intel, Ohio universities and community colleges, and the National Science Foundation to basically bring back semiconductor manufacturing, reshore it back into the United States to really be able to address some of the critical supply chain issues that have emerged during the pandemic. And so in this case, there's collaborative research projects to build semiconductor specific curricula for associate and undergraduate degree programs to help with workforce development. And then of course, also, there's the partnerships to be able to drive new technology development as well that would enable, satisfying some of the issues that resulted in these technologies and these capabilities being moved offshore. So the regional innovation engines are meant to cultivate new regional innovation ecosystems throughout the US. They are meant to address major scientific technological goals while solving societal challenges, and then balancing technical and geographic innovation. And so we've seen, as the decades have gone by, that certain areas and regions of the United States have remained quite strong in technology development and having their own ecosystems, yet while others have not seen that sort of growth, and in fact have seen attrition, due to certain areas having more infrastructure and more capabilities and more interconnectivity. And so the goal is really to sort of spread this out across geographic locations throughout the United States. And of course, there are several important, what one would call is, user inspired challenges to be met. And these include climate change, equitable access to healthcare and education, and then critical and resilient infrastructure. And as I mentioned earlier, there are some focus areas, including artificial intelligence, advanced manufacturing, wireless, quantum information science, semiconductors, and biotechnology. And the goal is, how can we leverage all of these different areas to solve these critical challenges that society is experiencing at this time? So NSF engines have a very different approach. So, as I mentioned earlier, that the idea is that it would be an iterative co-design, co-creation through intentional engagement of broad and diverse stakeholders, users. So very, very multidisciplinary, very much people coming from different walks of technology, and maybe even not having technology. There may be a social behavioral element to this that isn't necessarily considered, a specific hardware technology development or software technology development. There's cohort-based training and evaluation of the overall approach. There's milestones that are requirements to achieve continued funding that are being put into place in this program. It's going to be different to scale. So the idea is, if you have a region in the country that you're looking to find stakeholders in, for example, you could be having industry partners, nonprofits, you could have private companies, both large and small private companies, academic institutions of higher education. So all of those, could be stakeholders and players in this larger ecosystem. And from a systems design level, like how do these how do these parties work together to create solutions? And then how do you scale that out of your region, for example, maybe to another region? Is some of the considerations that are being discussed and in the process of evolution. So there are focused expectations for success. So, being able to show evidence of regional development, individual and geographic diversity, including mentoring, basically scaling, as I mentioned earlier, in terms of being able to reach out further and further to the benefit of, other areas in the country. That fact that IP ownership extends to all contributing parties to make it very robust. Be able to accommodate a changing culture. And then, of course, practitioner entrepreneur development. So having the ecosystem be able to, again, thrive on its own. So after NSF funds are sort of given to be able to establish these regional innovation ecosystems, once NSF funding has stopped, how is this ecosystem going to continue to thrive and support itself? So what is an NSF engine? And basically the idea is that, we have the NSF, the engine part, which is basically all of our different directorates that have fundamental research being supported in all different areas, of academia. And so that's what, NSF can bring to the table is the funding that goes into those academic research institutions. And then also this funding that we have dedicated towards translation and catalyzing this innovation ecosystem where, each region may have, certain strengths that they can bring to the table and then also partner up to be able to, to find that cross-disciplinary areas, gaps where they need to actually fill in those gaps. The idea is that engines are led by CEOs. And in this case, chief executive officers are thought of typically as, running a company. I mean, this is an ecosystem. And so the real goal here is to find somebody that has a strong ability to think in a systems design type of ecosystem. So, being able to look at complex situations and be able to guide them, be able to guide multi-disciplinary stakeholders, institutions that have very different ways of, running their operations internally. And so the goal is that each of these would have a lead, such as a CEO. And there are program deadlines that are quickly approaching to include, the concept outlines for a type 1 and a type 2 proposal. Type 1 proposals are about $2 million and type 2 are roughly $160 million. They're much, much bigger. Type 1 letters of intent are due August 31st, and then type 1 full proposals will be due September 29th. And then, of course, you can learn more by signing up at this this website here, the web link that we have on this. And in this case, you can also basically learn more about the program, what it's meant to accomplish, what our goals are, and, what might go into a letter of intent and a concept outline to receive feedback to see if it is, fitting the solicitation. And so then that's like our biggest, newest program. It's much, much larger scale than many of our other funding mechanisms that we have at NSF. So at this point, I'm going to segue to, the ones that are smaller and have been around for quite some time. And so that includes ICOR, which is known as Innovation Core Partnerships for Innovation, America's Seed Fund, which is our SBIR STTR funding mechanism, Pathways to Enable Open Source Ecosystems. That's a new one for us as well. It's basically a dear colleague letter that is requesting certain certain solutions to enabling open source ecosystems. And then, of course, Convergence Accelerator. So I'll start with Convergence Accelerator. And this is a program that can have several different entities applying to it. It can be basically academic institutions, it can be nonprofits, it can be institutions of higher education, and also for-profit or for-benefit companies. The way the Convergence Accelerator works is that, again, it is considered a multidisciplinary, multi-stakeholder effort. So, collaborative research beyond just the borders of your own, say, business or your own academic institution. It's run based off of cohorts. So in 2019, we had 2 cohorts, track A, track B, which one was open knowledge networks and the other was AI and the future of work. And then 2020, 2021 had several different, sort of user-defined topic areas for focusing solutions onto. And so 2022 has 4 tracks. One of them is securely operating through 5G infrastructure, which is joint with the DoD, enhancing opportunities for persons with disabilities, sustainable materials for global challenges, food and nutrition security. And this, the idea here is that that you're driving solutions in these categories to meet, problems that have been identified in the community. And there's this one's also a phased approach. So there's basically 3 phases of this. The very first one is sort of the idea stage. What is this going to look like? Who are going to be the players in this collaborative research effort? Then the second stage is, you get funded at a smaller amount of money to basically work with those people that and entities, institutions that you've identified to really develop and define what the research program would be to solve the challenge, and then what would be the milestones and metrics that you would put into that. And then that third track is getting funded for doing that work, where then you are held to the milestones and the quantitative success metrics that you had defined in the proposed work. And in this case, the last phase is tranched in years. So there is accountability before any additional funding is dispersed. So meeting those milestones, and not everybody makes it from track the second track to the third track. And if I recall correctly, I think the ideation stage, there isn't necessarily any funding for that, but then the second stage there is about $500,000 of funding. And then in that third stage, it's upwards of $5 million of funding in order to be able to execute through the full program to achieve the desired outcomes. Another funding initiative is the NSF GEM Inclusion and Innovation Initiative. Basically, this is a cooperative partnership between NSF and the National GEM Consortium, and it's focused on developing a national diversity and inclusion infrastructure for the Innovation Core program. So really, the goal here is to support underrepresented academic research and helping them launch successful technology startups by providing them entrepreneurial training. And the goal here is to also increase participation of underrepresented communities in innovation activities and really being able to tap into the entire ecosystem of innovation and just the talent that we have throughout the United States in all different areas and from all different populations. Another funding mechanism is the Innovative Postdoctoral Entrepreneurial Research Fellowship, also known as IPERF. It's a new career pathway for entrepreneurial-minded degree holders of doctorates in science and engineering. So, when you finish your PhD, not everybody wants to actually go into academia as their final, pathway for their career. And so oftentimes people will go into industry and, some will try to start their own businesses, and trying to start a business from a startup or business from scratch can be really difficult if you've never had any exposure to this. And so the goal of this program is really to provide that exposure. And so the individuals who apply to this program, that are interested in the program can apply and say that they're interested in it. And then companies that have been awarded an NSF grant in terms of an SBIR, STTR grant, they also can apply and say, we're looking for, postdocs to help us with our, research that we've been funded to do through the SBIR, STTR program. And it can also be, there could be other pathways outside of SBIR, STTR. But the goal here, again, is to broaden participation in small business innovative research and high-tech entrepreneurship, and provide non-academic opportunities to be able to really explore the landscape of how does research, happen when in the private industry, and then, what does translation look like? How do you take an idea that is, very much research oriented and translate that into a product? How do you commercialize it? So you can really learn a lot. And through that experiential learning, you can take that away and say, potentially start your own business to be able to be successful and work through some of the issues that are typical of startups. Another program that we have is Intern. This one is basically non-academic research internships for graduate students and also postdocs that are currently working on an NSF funded grant at a research institution. And this funds up to about $55,000 per 6-month period for graduate students to go work at a company to be able to gain that exposure as well. And typically the work that the graduate student is doing at the university has some tie to the NSF funded work that is going on at the academic research institution. And I forgot to mention, but going back to iPerf, I believe this is a $76,000 grant that can be used to pay the postdoctoral candidate in a salary at the company. And then, so Innovation Core is sort of the beginnings of taking a technology that was originally fundamental research at a university, or basically at a university. This has to be typically was something that had to be funded by NSF again. So it had to have NSF research lineage. And the idea is to help move that out of the lab and into the marketplace. It has since grown, and we now have hubs and nodes throughout the United States, and people that have started businesses or have started startups are now able to, approach a node and participate in a regional I-Core to be able to do sort of the same activities. So the goal of the I-Core, was to help scientists and engineers understand what it is that the market needs, and how to, once that's identified, how to basically evolve their technology through research and development to be able to meet that market pain point or market need. And so it was, a $50,000 grant to support those activities of customer discovery. So getting out of the lab and really finding at least 100, different potential customers, and having those conversations with them. So having a 20-minute to 30-minute interview to really learn, what problem could my technology solve? Who might be my customers? Do my customers want something more efficient, smaller, or cheaper? Do they have a return on investment if they were going to go? Even though my technology could be making something better, if it takes 15 years to pay off that investment, it's oftentimes maybe not going to be some risk that the markets would take. So really finding the answers to those types of questions. And then developing your research curriculum around that. So far, since its inception in 2012, there have been over 1,900 NSF teams that have gone through the program, and over 1,000 startups created. So Innovation Core can be something that researchers and graduate students and even faculty can participate in to start. But then also, if they are awarded a Partnerships for Innovation grant through NSF, which is what I'm going to talk about next. This is often something that's required if they haven't already done I-Corps. And then again, we have a mini boot camp in the SBIR STTR seed fund that will go through, instead of 100 interviews, customer interviews, you do about 30 customer interviews. But there's also the opportunity for a supplemental $25,000 award for to be able to have I-Corps participate in an I-Corps in conjunction with the grant that you have with the seed fund. And so the important point is to get out of the lab and talk to people. So the next step after you have, say you have a fundamental research grant funded by NSF and there's success in it, and it looks like it may have application to some marketplace, that researcher can apply for a Partnerships for Innovation grant. There are two tracks here. There is one where it requires partnership with an industry stakeholder, and that effort can last up to 36 months, and there could be $550,000 dedicated towards taking that fundamental research into an applied sort of research effort and de-risking some of the high-risk elements that prevent it from even being considered applied science at that point. And then there's also a tech transfer where it's just the one institution, but you're still kind of doing that same de-risking, to identify, maybe what market it could go to. And that would be an 18 to 24 month effort with $250,000. This doesn't require that anyone be employed at a small business because the applicant is actually coming from the academic institution. It's open to any technology covered by NSF. And, in most cases, there would be at least some kind of prototype that would demonstrate, some amount of feasibility, something that maybe would be enough for a company to come in and say, oh, okay, you've de-risked it enough for us to now be interested in, and we would like to take it and commercialize it. Or it may take it to a stage that would be appropriate for the NSF seed fund grant. And so that brings me to the SBIR STTR portion of our funding, which is where I, as a program director, reside. So our program invests up to $2 million in seed funding, and we do not take any equity. And the difference here is that the applicant to this program has to be a for-profit or for-benefit company. And whereas the other ones, there are certain, criteria that it has to be an academic institution that has NSF research lineage, or other ones have the purview, like Convergence Accelerator, allow you to apply as, an academic institution or a nonprofit or as a company. But this one is specifically, the company has to be the applicant. And so we're focusing on transforming scientific and engineering discoveries into products and services that have commercial and societal impact. There still needs to be some high-risk element in all of our grants for phase one that requires significant R&D that would produce some fundamentally new knowledge, and ideally produce something that you could, consider intellectual property that would give you a durable competitive or a sustainable competitive advantage as a business. Each year we have about $200 million that go into this program, and we fund about 400 startups across the United States. Typically we have about a 10 to 15% funding rate for phase ones and about a 25 to 40% funding rate for phase twos over the last few years. The projects that we fund should have a positive benefit to society and lead to significant outcomes in the commercial market that can create a sustainable business model. So I always say, when we fund a company, we want to make sure that they can sustain themselves and that they do not keep coming back to our program, because it's not a sustainable model for our program to have companies continually come back to try to get grants to develop stuff. So being able to commercialize the technology to generate revenue is extremely important in our program. So most of our startups that we fund have fewer than 5 employees and have been recently formed and haven't received funding from the government before. So we have a phased approach as most SBIR programs go. The phase 1 is feasibility research. It's typically 6 to 12 months and up to $275,000 for the grant. Phase 2 is research towards a prototype. That's 24 months, and you can request up to $1 million to complete that. We have several other supplements, one of which is a phase 2B. If you receive a phase 2 award and you are able to obtain third-party investment, either institutional investing, or it could even be revenue generated from the project, initial revenue generated, we do a 1-to-2 match. So if you have $1 million of investment or revenue generated, we can match up to $500,000. To qualify for the SBIR, SBIR, you have to be set up as a for-profit organization, which can be also a for-benefit corporation. It has to have 500 or fewer employees, including the affiliates that are associated with the company. It has to be located in the U.S., and then the work has to be performed in the U.S. It also has to be 51% owned and controlled by U.S. individuals, citizens, or legal residents. And the outputs, so our recent phase 1 awardee stats, 95% have 10 or fewer employees, 81% founded in the past 5 years, 59% are first-time SBIR, STTR winners. The outputs of our portfolio since 2016 to 2021 is that there's $14 billion in follow-on institutional equity financing for our companies, which is pretty amazing. And there have been 200 successful exits, including acquisitions, mergers, and IPOs to comprise those 200s. We have several examples on our website that I welcome you to go and visit and check out, so you can get a feel for sort of the types of companies and types of technologies we've funded in the past. In this case, we're showing an awardee that's a company called Diligent Robotics that was started by Andrea Tomasz, Vivian Chu, and Agata Rozga, who are creating basically a robot and robotic technology that will assist nurses in being able to effectively and more accurately deliver care to their patients. And for those of you who don't know, many of our there's a nursing shortage, and many of our nurses really have a large patient load, and so this is meant to really help with that. So our SBIR STTR awards are funded in several different technology areas. So on the right side, it's basically general areas of technologies, and on the left side, that is, there are basic areas that we fund. So photonics and semiconductors, materials manufacturing, electronics, IoT and robotics, chemistry and environment, information technologies, and life sciences. This isn't indicative of where we focus our attention to. This is just basically what has been submitted to our program, has been competitively evaluated and awarded. And so that's just a reflection of where we have awarded our funds. And on the right side are the different portfolios that we have. Each of these portfolios has subtopics. So if you were to click on this on our website, you could see different subtopic areas that, that particular portfolio is, sort of looking for technologies. We're not technically looking for the technologies, but it's areas that we've identified that have some kind of critical mass or importance in sort of the commercial space. We always have one here that I like to say is other topics, because we do not prescribe to anybody what they should be addressing. We really want you to go to the markets, identify the needs, and come to us with it. And that's why we have other topics, because sometimes it doesn't fit in any of these. It might be a new and emerging market and a new and emerging need, because there's some new fundamental research that's very, very different from anything else that's been going on there. And that's why we always say other topics is there. So keep that in mind if you don't feel like your technology fits in any one of those particular categories. So how to get started with our program? Step one is basically submitting a project pitch. We have a lot of inquiries coming into our program, and so requesting that the program director meet with you is we have very limited bandwidth to be able to, do project pitches, do the full proposal analysis, and then manage the companies that we have. So we have this project pitch, which is really the first interaction that you'll have with a program director. I always say, please do visit our website and look for the webinars and the Q&As. Please do sign up for one of those. Definitely watch the recorded video we have. It gives you a lot of information that is common for many people to ask. So, it's not really the most effective use of a program director's time to be answering the same questions over and over again. So we ask that you do go to our website, check out our webinars, and sign up for a Q&A. The Q&As are hosted by individuals like myself, so you can actually ask your questions directly there to me or any one of my colleagues. And then in that, you also get the benefit of being able to hear your colleagues or anyone else interested in the program and their questions. So you learn from that process. You will get feedback from us within a month, oftentimes like three to 4 weeks, and you'll receive feedback. If your technology is considered a fit for our program, then we will send you an invite. If maybe there's not enough information, we will send you that feedback back that perhaps there's not enough information for us to make an assessment, and where you should consider adding more information into the pitch. And then if it's not a good fit because it just doesn't fit with our solicitation requirements, we'll also let you know that. And then basically the purpose is really just to assess fit with the program. We have 3 review criteria for full proposals that are submitted. It's intellectual merit, broader impacts, and commercial potential. If you're invited to submit a proposal, I highly recommend that you read the full review criteria, both in our solicitation. There's also a section on our website for reviewers, and so you can read those and understand what is it that our reviewers are asked to evaluate in the proposals. So then what do we fund? We fund research and development to overcome significant technical hurdles, novel and proprietary, it should be novel and proprietary innovation. There should be a proof of feasibility, viability of the new product, process, or service. There should be high technical risk, especially in the early stage development. What we don't, I'll go over what we don't fund in another slide. There should be a significant commercial opportunity. You should have at least evaluated what other possible things there are, like what other possible technologies are out there. What's the current state of the art? Are there other companies that are functioning in this space? And then what is it that you bring to the table from basically a features perspective, and then also value proposition that would drive somebody basically buying this product. And so the product market fit is validated by customer interaction. So that's where iCore helps. If you don't have access to iCore, I highly recommend still doing some initial customer discovery. So what we do not fund is basic research with the primary goal of knowledge creation. So if your idea is really, really cutting edge and there's no literature to support it out there, there's really, you'd have to create new scientific theory in order to evaluate it. That is not a fit for our program. That's fundamental research. Incremental and evolutionary improvement to an existing product or service is also not considered responsive to our solicitation requirements. So if you're putting together commercial off-the-shelf products together to create a new product that has maybe some benefits to it that are above and beyond what's currently out there, that typically doesn't fit. If for whatever reason it does require new research and development in the way that you are putting some things together, and the potential resulting features and benefits are orders of magnitude better than what's out there, that may be something that might fit into our program. And I would always recommend submitting a pitch in those cases to get feedback. Projects where there are no strong chances of commercial success, or if there's nothing even considered in that commercial market space in the pitch, then that would cause us to say, this doesn't fit with our program. And if the idea is that we're looking at big impact. So if NSF funding can't make a big impact on the company's prospects, then it's not a good fit. If you're a revenue generating company, and you're generating lots of revenue, we're looking at startups who aren't necessarily in that space. And so keep that in mind that, the big impact has to be there as well for the funding. Analytical or market studies of existing technologies or products service also is not something that we fund. So there are several ways to engage in our programs. One is as an applicant. And so to apply, you can look at our website, seedfund.nsf.gov for our SBIR STTR program. You can look at iPerf at this web link. And then also for the other funding mechanisms that I mentioned, you can go to nsf.gov and the TIP Directorate to understand more about the regional innovation ecosystems, the Convergence Accelerator, and any of the new sort of potential funding mechanisms that'll be coming out over the next couple of years. You can also engage as a reviewer for our programs, and you can send your CV to SBIR@nsf.gov. Serving as a reviewer is a great way for you to, engage with the community, understand, our review criteria, understand the process that we take to review proposals. And then also give back to the community. I always say it's great to be able to, give and receive from this program. And then also we are looking for program directors for the SBIR STTR program. And we're looking for folks that have experience in roles that are related to commercialization of innovative products in either small or large businesses. Recent experience with technology startups or small businesses or with early stage technology investments is something that we are looking for. So with that, I conclude the talk today, and I'm thank you for your attention, and please do let me know if you have any questions. And with that, thank you for your time.
Hi, Ella. We do have a lot of great questions that have come into the chat. Can you hear me?
Yes, I can.
Okay, so hold on a second. I'm going to grab a mic so the audience can hear me.
Okay, sorry, we're checking for feedback. All right,
okay.
So the first question that we're going to ask is about citizenship requirements for most of these programs. Do you have to be a U.S. citizen to participate?
So as far as, being a PI or an employee in the company, you don't have to be a citizen. Employees can have visas to work for the company, but the company has to be owned either by 51% or more by a citizen or a permanent resident. But employees can be, folks that have visas to work in the U.S. and the work must be done within the U.S. borders.
Okay, great. And where's the best place on NSF's website to see a summary of those kinds of citizenship requirements? Is it just under each program there will be that specific info?
So in this one, it would be in the SBIR STTR program. So I would recommend going to SBIR.gov, which has, all of the information about eligibility for the SBIR STTR program, as that's, dictated by the SBIR program that was rolled out under Congress's purview. So,
and now we have a question about iPerf. So what does the matching process look like when iPerf is matching postdocs to companies?
So as you can see here, it's administered by the ASEE. So the funding, NSF provides the funding, but the administration, the whole process is through ASEE. And to my understanding, you go onto that website and you indicate your interest in becoming a postdoc, and then companies indicate their interest. And the companies will have to be approved, right? So there's only so many numbers of seats available. And so those number of seats, can be maximized in terms of, maybe there's more applicants than there are seats. So keep that in mind. But once, the company has been approved, then basically, I believe there's a database where people can see what companies are looking for, and then companies can see what applicants have as their background. And so that process ensues just through looking through CVs and looking through the job descriptions, right? So somewhat
if I
traditional.
understand it correctly, the way that this works is that on the company side, the supply side for these positions, those are all NSF funded companies. But we also had a question about whether the the applicants to IPERF have to be NSF funded. My understanding is that it's only the companies that they go to that are NSF funded, right?
Yes,
Okay.
the postdocs do not need to in this case. That was just with the intern. The intern is where the graduate students or postdocs have to be funded by NSF. So, but for the IPERF, that's not the case. The postdocs can be any postdocs throughout, any organization.
And so with IPERF, what you're saying is that the number of open positions is variable, and it sounds like it's really similar to a job interview, right? So there are companies, and then you'll submit a CV and you'll get matched that way.
Mhm.
Of course, there's just 4 applicants and 4 companies.
Yeah, and sometimes those relationships are forged before that, and then the companies apply already knowing. So, to forge a relationship with a startup, you can do that before applying to the program too. And so, because sometimes folks will be looking to see who we funded, postdocs will be looking to see who we funded, and they'll maybe find something that's of interest to them, and they'll reach out to the company. That I've seen that happen in the past. So there's no specific exact way that you do this, but you do have to apply in order to be able to have the match be recognized and funded through NSF.
So that's really exciting. So someone might know a startup and they know that they recently received an SBIR phase 1, and they can say, you know what, I'd love to come work for you, and it would be free, essentially, right? Through IPERF.
Yeah.
Okay,
Exactly.
so that's actually, I think, of a great interest to our audience. They can create opportunities that way. Okay, so next question is, what happens with previous tracks in the Convergence Accelerator? How do we understand how to engage with these ecosystems after their phases are complete?
Can you say that one more time?
What happens, so what are the outcomes with the previous tracks in the Convergence Accelerator? How can we better see what those outcomes are like?
So yeah, so that one, I mean, it's still a fledgling program in that the 2019 cohorts are just like starting their phase 2. So it's not easy for me to just tell you, kind of what those outcomes are. The best way to look is to visit the site, and you could reach out to any one of the awardees to talk to them about, their programs. But I would say that we have yet to really have that outcomes.
It's essentially just too new, really, for us to have solid data. Okay.
Yes. Mm-hmm.
In general, which programs have had the most successful amount of technology transfer?
Well, we have not actually done that data mining process. So we don't know as a comparison which ones have had, the greatest success in translation. We individually, as looking at the programs and their ability to drive translation, each one has continued to stay in existence as a result of providing sufficient, evidence that translation is occurring, and that, that is important. But I don't really have data to tell you which program is better than another in terms of translating technology.
I think that makes sense. I think we always like to know where data is available and where we can look at that and better understand it. But it's great to be transparent and say where it hasn't been done as well. But the next question is, generally, how does NSF best support early career investigators in academia? What are the best opportunities at early career?
Right. So there is a career grant that, that I think the first 3 years of a faculty career is where this grant is applicable. And so I didn't speak to that one per se, but you can find it if you type in NSF Career Awards. And so those are something that one can get for early stage funding from NSF. And that's the best I can sort of tell you about that program.
Okay, and this next question, I think it's a little bit more maybe your personal take on it. The question is, how does culture play a role in bridging academic practice with business practice?
Yeah, well, so, I mean, it's an important thing in our, especially in the SBIR STTR program, because we do see a lot of, technologies coming out of the labs. And so it is important to really understand, what it takes to translate. And, things that we've seen in the past are if an academic faculty runs the program at the academic side and then runs the program for the SBIR STTR, say, on a sabbatical, and then, wants to step away. It's really important that part is very well thought through in terms of you're going to start this train running down this track, and then you're going to disembark at some point. Who's going to keep it running, and, how and why? And so to me, that's where culture comes in, is where, can you find the team? You have to build the team during the phase one and really work hard to find who are going to be those people that are going to take the technology to the next step, right? And who's going to be the person that has that business development prowess, and who has the tech part is usually not an issue when it comes to translating technologies out of the institutions. There is a little bit of a hiccup when it comes to going from research and development to more engineering design, right? So our phase 2 programs in seed fund, they're looking at commercialization. So those high risk elements aren't going to be there, and the R&D is going to be a little bit more straightforward and not as risky. And so as that goes, when you finally have a product, who do you need within the company to support that product's placement in the market, right? And really thinking those roles through and how you're going to build that company. So that's kind of the best that I can state about culture at this point, from the perspective of academic institutions moving technology out.
Well, it's always helpful just to get some insights and thoughts on that. I think we have time for one more question. And so a question, that I think a lot of our postdocs have. So it's noted, many of the programs seem to require current funding by NSF in order to apply. And so for that first step to get on the road, what are your best recommendations for someone who's moving along those first grant stepping stones as an academic?
Yeah, so I would say oftentimes each university has some resources, right? So the VPR is like one, somebody who is engaged with considering the research innovation ecosystem and translation, right? And so what other potential resources are there at the university? Each university is a little bit different, but there is effort at many universities to try to help with that. So the first step I would say is to find out internally what does your university offer you in terms of help? For me, it's always customer discovery. Has anyone else at your institution or anyone else in your network translated science out of the lab? And go and have coffee or lunch with them and just talk about that experience, and start to understand from that perspective, like what was important. And so that gives you a little bit of understanding the lay of the land in terms of what to sort of expect, and then areas where you're like, okay, that makes sense to me, but this doesn't make sense to me. So maybe I should talk to somebody about this aspect of it. So reaching out to your network after, whatever you have internally in your academic institution, broadening it a little bit further. And of course, we have all our resources that sort of tell you, these are the things we want you to focus on, because we've picked those things to focus on because we know that that's been, essential to the success of companies, translating technologies. So in the end, I would say from what, we have at America's Seed Fund is our website, which has a lot of resources in terms of, what is your market, understanding why we put I-Core together. Most of the programs that we rolled out were as a result of seeing a gap in knowledge. And so going in and, doing an I-Core is an important part of customer discovery, understanding how to do customer discovery, realizing whether you want to be the one who does continuous customer discovery as the company continues on, or whether where your role is, what do you prefer to do. And then SBIR.gov also has some good resources. So that's kind of where I would say, starting internally to your organization, then your network, then look at sort of what we have. And you'll probably, by going through that, you'll probably understand what we're asking for a little more as well. that makes any sense.
I'm just going to throw in one last, hopefully quick question. So of course, here on the slide, we see that program director is the way to engage. Is that a realistic job to apply to for somebody with a postdoc if they have some experience working with startups? Really, what does the candidate for that position look like?
The candidates in that position typically have significant experience in that realm. So I would say maybe as a postdoc, like if you've had industry experience prior to then going to get a graduate degree or a postdoc, you know, that industry experience can be relevant. And so, and then having the technology aspect. So that might make somebody competitive for a program director position. But, you know, we always say, you know, how much, you know, do you have the scars and the success stories from dabbling in this entrepreneurial space? And so that's kind of a requirement. But I put it out there just in case.
You want someone a little battle hardened.
Yes, little battle hardened, and you know, success stories, and you know, so you know, because as a program director, once we fund a company, you know, we're basically with them through phase 1, and if they're successful, phase 2, then we're there the whole time, and we've seen a lot, and you know, we have our own experiences. So as they approach and experience certain things, you know, we can, you know, have some discussions and provide some line of questioning to really help those small businesses and startups, you know, think through what their opportunities are, right? So.
Well, speaking of that, we actually have an alumni startup that asked us to give you a special thank you. That's Frontier Bio. Thank you for being with them.
Great. We're excited, you know, to see any new ideas and applicants come through our programs. That's what they're here to help you and help the world and help make the world a better place.
Okay, everyone, can we give Ella a hand? If we're loud enough, she can hear it.
Thank you much. Take care, everyone.
Thank you so much for being with us today. And I think
Bye-bye.
we will all be in touch.